Here is the next video. I'm still going over the quizzes. It will helpful for you to take the final exam. Now, the first question, two 3 farad capacitors are connected in parallel. This parallel combination connected in series with a 3 farad capacitor. What is the total capacitance? So basically, two 3 farad capacitors are connected in parallel. This is connected in series with another capacitor. So what is the total capacitance? So what is the capacitance between AB terminals? So this is 3 farad, 3 farad. When two capacitors are in parallel, it's just a direct addition. Okay, 3 plus 3, which is 6 farad. Now the 6 farad is in series with 3 farad. So 3 farad and 6 farad, they are in series. Now here, to find out C total, you have to use the parallel formula, 3 times 6 over 3 plus 6. Okay, you will end up with 2 farad capacitor. Okay. Now, next question, a resistance of a conductor is 10 ohm. What will be the resistance of the same conductor if it is stretched twice longer than its original length? Assume that no extra material is added to it. So we know that here is a conductor, R equal to rho L by A. What we did, we stretched. So basically, let me draw. This is the conductor. Okay, now I stretched this double the length. So material is same. Let me take this as R2. Material is same. It's not going to change. So rho length become 2L. Now when I stretch it, assuming no extra material is added, what happens to the area? Area is going to be half. So when we stretch any material, conducting material, when we double the length, cross-sectional area is going to be half. Okay, so it's going to be 4 times rho L by A. So 4 times 10, which is 40 ohms. Which of the following statement is true about the, I didn't complete the question here, problem talking about electric field and current. There won't be any electric field in current carrying conductor. That's a false statement. Electrons moving in the conductor because of the electric field, that's a true statement. Okay, electrons are moving inside the conductor because of the electric field. Electric field and current are not related to each other, that's a false statement. More resistivity of the conductor will allow more current. I mean, that's also a false statement. We know that if resistivity is more resistance means less current is going to pass through it. Now, electron drift speed is typically extremely slow, moderate, very fast, or equal to speed of light. Electrons are always move very slow inside the conductor, but energy moves at the speed of light. Now, a positive electric charge is moved at a constant speed between two locations in an electric field with no work done by or against the field at any time during the motion. This situation can occur only if the charge is moved in the direction of field, the charge is moved along the equipotential line, charge is moved opposite to the direction of field, and electric field is uniform. Okay, so basically, if you need to move an electron, say here is electric field. Okay, this is the electric field. Now if I need to move a charge from here to here, for sure, or anywhere, we need to spend some work or some energy to move the electron from one place to another place, because we know that this is positively charged, this is negatively charged, then only electric field is going to go in that direction. So to move this either electron or proton from one place to another place, for sure we have to spend some energy. Now, but to move the electron in this line, this is called equipotential line, we don't need to spend any energy. So charge is moved along an equipotential line, then we don't need to spend any energy. That's what it says. Okay, now the next one, okay. Match the following. So volt, I mean coulombs per second is nothing but current, so which is ampere. Okay. Now joules per second is nothing but watt. Okay, so and Newton per coulomb is nothing but electric field. Electric field has another unit which is volt per meter, and joules per coulomb is nothing but volt. So that's the combination. We just did this exam, this question in the previous quiz. We did this in the previous quiz too. We did this in the previous quiz too. There won't be an electric field. So true statement, that's the true statement. And this is the true statement. Now last question. What resistance should be connected across a 9-volt battery to make a 10 milliampere current? It's just Ohm's law equal to V over R. I don't know why I asked this simple question. 10 milliampere. So 9 times 10 to the power of cube over 10, which is 900 ohm. Okay, so basically this is R equal to 9 over 10. Okay, 900 ohms. Okay, here is the next question. If the ammeter reading is 0 amperes, what will be the value of R? So basically, whatever current is supplied by the source, say this current is supplied I ampere. Okay, so I ampere is going to split in two paths, I1 and take this as I2. Okay, now the same I1 must pass through this same current I1, and here it must be the same current I2. He's saying that ammeter reading is 0 amperes. So if it is 0, look at this. Here we have 1 ohm, here you have 3 ohms. Here we have 2 ohms. For sure this must be 6 ohms, then only the current passing through this ammeter must be 0. How did I come with that conclusion? Because we can we can apply KVL at this point. Kirchhoff's voltage law, we can apply KVL at this point. The voltage at this point and voltage at this point must be equal to 0. Then only this ammeter reading will equal to 0. So from that you can calculate this value. Okay, but when I look into the diagram or circuit, I can clearly see whatever current, if the same current has to pass through this 1 ohm and 3 ohm and 2 ohm and this R must be 6 ohm. Okay, so 6 ohms is the right answer. Now if the current, let me go through the third one, looks like easy, and then I'll come back to the second one. If the current passing through this circuit is 2 ampere, so the current passing through this 2 ampere, what will be the resistance R? So here clearly this is 12 volts and 6 volts, they connected in opposite direction. I'm going to simplify the circuit as a 6 volt. Now all these resistors are in series, so total resistance is 0.3 plus 0.2 plus 1.5 plus R. Okay, and he clearly mentioned there is a 2 amperes current is passing through this. R equal to V over I, 6 over 2, that's a 3 ohms. So 1.5 plus 0.52, so what is R value? R value must be 1 ohm. Okay, now second question, if the current passing through the circuit is 2 amperes, then what is the energy dissipated in resistance in 60 seconds? So he's talking about total energy dissipated in 60 seconds. So we know that R equal to here 1 ohm. What is the formula for energy? I can say energy equal to P times time. Okay, P is nothing but I square times R. He already gave you I square R, V times I. We can use V times I times time. Okay, so the total V you can see, which is 6 volt, I 2 ampere, and time is 60 seconds. Okay, so what is this? 12 12 times 60, 720 watt second. So this is in watt and this is in second. Watt second is nothing but joules. So 720 joules. Okay. Next one, which of the following circuit has the greater current from the source? So we know that resistance opposes the flow of current. So whichever has the low resistance, that has more current passing through it. So this is, for time being, I'm going to take V equal to, everywhere V is same, let me take V equal 10 volt. Okay, in this circuit, 10 divided by 2, this is 5 ampere. In this circuit, 2 and 2 are parallel. So 2 equal resistors are in parallel, then resistance value is 2 divided by number of resistance total. Okay, so this is 1 ohm. So I equal to 10 divided by 1, that's 10 ampere. So I can see out of these two, this is more. Here 10 divided by 4, it is 2.5 amperes. Here 10 divided by 2, because 4 total, resistance divided by number of resistors. So that's 5 amperes, 5 amperes, 2.5. So A is the right answer. Now, in a 30-minute interval, 1 kilowatt hour of electrical energy is dissipated in a resistance of 20 ohm. What current is talking about? So basically, energy equal to P times time. P is I square times R times time is 30 minutes. So I'm going to convert that into hour, half an hour. So this value is given as 1 kilowatt hour. Okay. So what is the I value? I equal to 2 kilowatt hour get cancelled. 2 kilowatt divided by R value is given and square root of this will give you current, which is 2000 divided by 20 square root of, is it 100? Square root of 100 is nothing but 10 ampere. Okay, next question. A 6 ohm resistor is parallel with 3 ohm resistor and the combination is in series with 4 ohm resistor. What is the equivalent resistance? So you have 6 ohm and 3 ohm, they are connected in parallel, series with 4 ohm. Okay, so 6 parallel with 3, this is the symbol for 6 parallel with 3, 6 times 3 over 6 plus 3, which is 2 ohms. So 2 plus 4, 6 ohms, are total equal to 6 ohms. I used to think when I was a student, okay, we already have 6 ohm resistor, why do we need to combine all these three to get the same resistance value? But probably we know that resistance converts electrical energy into either heat energy or light energy. So probably this 6 ohms is in one room, either producing heat or light. This 3 ohms is another room producing light or heat. This is another room producing heat or light. Now I have to find the total resistance, so that way I know what kind of wire I need to use to manage that current in that circuit. Okay. Next one, a 10 ohm resistor is in series with 3 farad capacitor. This series combination is connected to a 6 volt battery. What is the energy stored in the capacitor? We know that capacitor acts like open circuit in DC once it is fully energized. Okay, now here RC, what is the formula for energy stored in the capacitor? Half CV square. We know that half C is 3 farad, V square is 6 square. By the way, most of the time capacitors are going to be in microfarads or picofarads. So 36 over 2 times 3, which is 54. Okay. Next one. By using KCL, find the current I in the following circuit. So according to KCL, Kirchhoff's current law, current coming into the junction must be equal to currents going out at that junction. So 4 amperes is coming in, 1 going out, so 3 must be going in that direction, and 3 is going there, and 2 amperes is coming in this direction. I mean, don't get confused. Arrow is down here, amperes are down up there. It doesn't make any difference. Okay, same. 6 amperes is 2 amperes is current coming in. So I must be 3 plus 2, 5 amperes. Okay. Now, if two different rating bulbs are connected in series, which of the following statement is true? Same voltage across each bulb, but different current flowing through each bulb. So two different rating bulbs are connected in series. We did this example in the class. Okay, these two bulbs are connected in series. Are we going to have different voltage or different current? For sure, in series, current is same. So same current, but voltage is going to divide differently based on the resistance value for that bulb. So different voltage across bulb, but same current flowing through the each. Now ammeter always connected. Ammeter is to measure the current, voltmeter is to measure the voltage. Remember, current is always flow inside the wire, so it must be connected in series, and voltmeter must be connected in parallel, because voltage is always between 2 points. Okay, so series and parallel. Ammeter is always connected in series to the element, and voltmeter always connected to the in parallel to the element. Next one, at what value of R the circuit will have the maximum power? So for maximum power in any electrical circuit will happen for the load resistance must be equal to the internal resistance, but that's not the question here he's asking about. Now, to have the maximum power, P equal to I square times R. Okay, so to have the maximum current, you have to have the low resistance. So out of these, which one will have low resistance? So if I take this as R by 2, so each value as R by 2. So, first choice, if you take the first choice, R and R, the total resistance is R by 2. Okay, to make it simple, I'm going to simplify this as, let me take this as 10 volt, and let me take this as 2 ohms each. Okay, so in the first case, if I take this as 2 ohms and 2 ohms, then P equal to, or R total equal to 1 ohm, and current passing through that circuit, I equal to V over R total, which is 10 over 1 ohm, 10 ampere. Okay. So in the first case, P equal to I square times R, 10 square times, what is the total resistance? We have to use 1 ohm, so that is 100 watt. Okay, let me go with the third case. Okay, if I take R by 2, so basically I'm taking this as 1 ohm and 1 ohm. If I take 1 ohm and 1 ohm, what is the R total? In this case, R total equal to 0.5. So what is the I? I must be 10 over 0.5, which is 20 ampere. So P equal to 20 square times 0.5. Okay, 20 square is 400 divided by, 0.5 multiplied by 0.5, which is divided by 2, which is 200 watt. Okay, so if I have R by 2 resistance, then they are consuming around 200 watts. If I have 2R, so 4 ohms and 4 ohms, result is going to be 2 ohms. The current is going to be 5 amperes. 5 square times 2 ohms is less than 200. So C is the right answer. Now, which resistance consume more power? It's similar to the previous one. So voltage is same in parallel. Say if I take this as, let me take this as 90 volt. 90 divided by 9, how much current is passing through this? 10 ampere. How much current is passing through this? 90 ampere. So which one can use more power? P equal to I square times R. So 90 square times 1 or 10 square times 9. 90 square times 1 will is bigger number. Okay. Next one, 2 light bulbs of 120 volt 60 watt and 120 volt 100 watt bulbs are connected in series. Which bulb glow brighter? 60 watt bulb glow brighter, because I mean these are the two bulbs. You need to find the resistance value. So a 60 watt bulb is going to have more resistance than 100 watt bulb. Okay, so more voltage drop across this compared to this. So that bulb will glow brighter. Next one, assume the capacitor is initially uncharged. Which of the following graph represents the voltage drop across the capacitor from t equal to 0? So we know that capacitor acts like a open circuit once it is fully energized, but to energize it will start to energize it will act like a short circuit initially. Okay, so once it's going to be in the exponential format. Okay, assume the capacitor is initially uncharged. Which of the following graph represents the current passing through the resistor? So initially there will be high current, and then current becomes 0 once it is fully charged. I will stop this video here, continue with another video, the rest of the